time to do some focused work. I already went to the gym. It's already almost 12. And I configured a bit of stuff for Twitch and YouTube. But now, I'm ready. I'm ready to work and get some stuff done. So today, predominantly study. That's the plan. Study for the subjects that I now have back in semester 2. And after all that, I'm gonna do a Leetcode question, followed by studying the Odin Project. But that'll come probably later in the day, quite later, depending on how much I can get done and how fast I can get it done for the subjects that I have now. So yeah, I think we'll just have to see, and how burnt out I'll be by the end of today, we'll see. And then if I can do anything from the Odin project and translate it to the app that I'm building, I'll do that too. So roughly 4-ish things that I want to do. You know, the more, I guess, dispersed each one of these are, the less deep work that I can get. But my thinking is I can get most of my deep work done in my study session. So in the study aspect of this stream, that's my plan. But we'll see how we go. And yeah. Okay. Just going to do one monkey type question. Eight. All right. Finally, go to APA. Oh, I just messed myself up. Here's the thing, guys. There's something that I gotta do real quick. This will take maybe like 10 minutes. Ooh. Thanks for the follow, whoever that was. God damn. That was loud in my ear. Oh, here we go again. Thank you for the follow, guys. Appreciate it. More. That's quick, man. How come they're just all coming in? Isalmani, thanks for the follow. Ooh. Being distracted actually. Ooh. Thanks for the follow. Nibby! It's Nibby! It's Nibby, yeah. Oh, where's the tutru? That's a good point. That's a good point. What happened to it? Oh, I'll tell you what happened to it. It was on something else. We gotta try it again. Give me a sec though. Twitch. Channel. I'm on my laptop. It is just default. You actually made me realize. I don't know, because I'm using this external alerts system. It's called Botrix. Except, gotta test it. Just gonna test it. See, like that works. But it must be something else. Let's see what it was as a Botrix activity. It's a follow. Yeah. So it's a sub. It's different from follows. Well, the only way that I can probably change that then is I'll have to see if it works when let me just try a followers. Yeah, that is different. Okay. Change the sound. I'm gonna do it here because I actually have the sound file on here. What? That's not even... Oh my god. That's not what I want. Unfollow me, Nib. Nib. What's a good GIF I can use? Oh, you can't chat when you unfollow. Use the Mr. Fresh GIF. I just realized what you mean. There's a voice text to speech.
This is a test message.
This is a test message. I don't know how sad that'd be. Wait. Okay, wait. I have to save settings, maybe. Do Chinese. Alright. Alright. Chinese. English Chinese. Let's see. Oh, I'm not even doing the right thing right now. I'm not modifying the right thing. Let me check again. Ping Long Wu be like. Ping Long Wu, you actually remember Ping Ping Long Wu. Okay, so that kind of works. But how do I change? Okay, yeah, no, its subscription is different, right? Voice TTS is Chinese.
这是一
So I don't
条
even
测
need
试
this.
消息。
I don't even need that. Alright, we'll keep it like this now then. Well, that fixes it. If you couldn't tell, the internet cuts out every now and then comes back in like less than a minute. That's the pain of my internet. $10 minutes. Hold up, where the hell is my Discord? $10 minutes, 10 of 6 is 1 in 6 of 50. Actually, I don't even know how much I charge. $60, I think I charged. Yeah, it is 60. 60. 1 in 6 of 60 is $10. Okay. Okay. Here we go again. Man. Okay. I can pull things back. Do this problem. Okay. Main thing. Oops. It's not what I wanted. Yeah, so SATs and CSPs are something that I want to write down so that I'm aware of it, at the very least. Satisfaction problems. Like, okay, so SAT and CSPs, AI solvers, a solver example. What is the example given by... What is an example of a solver? Solver is general, as deals with any problem expressed as an instance of model, linear equation model. However, is tractable. AI models are not. Solvers, tractable. I'm going to assume that's 34. Now let's see if that page goes to 34. So 34 is this. 35 is... Ooh. Let's try 36. It's too far. 35 maybe. Has to be 35 then. Click on it. That's not 33. Yeah, this is it. Gauss, Jordan, elimination. as a general solver. And yeah, what is the difference between a CSP satisfaction program and SAT? Okay, AI solver, the basic model, constraint satisfaction, or SAT, find state that satisfies constraints, planning problems, planning with feedback. SATs and CSPs. SAT, it determines if there is a truth assignment that satisfies a set of clauses. That's fine. Problem is NP complete, which is in practice means worst case behavior of SAT algorithms is exponential in number of variables. Sure, yet current SAT solvers manage to solve problems with thousands of variables and clauses, and used widely. Constraint satisfaction problems generalize SAT by accommodating non-Boolean variables as well, and constraints that are not clauses. Key is efficient polytime inference in every node of search tree. Polytime inference, so intuition. Unit resolution, conflict-based learning, many of the other logically possible but do not work, scale up. Okay, sure, there's more to read on this, but from my understanding, CSP is a more generalized version of SAT. Constraint satisfaction problems. Except I'll have to read a little more on what the difference is when I read the book, alright? And I'll need to have a bit of understanding about... Where's my V at? Yank, paste, undo, paste. We're gonna go page 35. Do I you know, AI planning might become useful in the scheduler app that I'm building. You know? Okay. Okay, so now that we've done that, we got to read up on search algorithms, which is the next handout. Basic stuff, you're going to need to search for a solution, where to search next, search algorithms. Sus. Blind systematic search, heuristic functions, informed systematic search, local search, conclusion. Lipovetsky, near Lipovetsky. Basic state model, classical planning, ambition. Write one paragraph that can solve all classical search problems. Hey Adam, dropping in to say hi and good luck with your studies. Thanks, man. Thank you a lot. It means a lot, your support. Hee hee. Alright, back to it. Yo, I'm Spasco. I'll hop back to Obsidian. Yes. I think that's just what I'm gonna stay with for now, you know? I could be bothered with Logseek. Like, as soon as you left, I was like, alright, I'm good. I think I've spent too much time. Yeah, just gotta pick a tool, stick with it, and actually get shit done. Yeah, that's it. That's it. That's the way. We'll see, any pain points that I have, I'm gonna just deal with it. And then just go with my day, do what I need, study what I need, and we'll be good. Oh, hello, hello, hello. I muted myself. Okay. So you said stenography was an elective? You wish it was. I think it shouldn't. Could you hear me the whole time then? Before that? Probably. Maybe. But stenography is like muscle memory. How are you going to teach it in a class? Except practical classes. The whole time. Yeah, it's freaking epic. What's your husband saying? Dad was shouting. Now they're talking. Random stuff. Random stuff. Are you done with uni yet? Did you just finish watching your lecture? Online? I can't access my stuff on Echo, bro. It's not live, but it says recording, but I can't tune in live. RIP. Yeah, that is a rip. So maybe it was worth going into uni today. Maybe. It was your choice. It was your choice. I didn't convince you anything. You chose it all by yourself. You know that pic looks like L1. From afar, from afar, from afar, from afar, from Jafar. It's like 3 pixels. Okay. Can you see those emotes? Of course I can. I can see the transgender pride flag emote. I can see it all because I have the Twitch chat open on the side as well as the YouTube chat. If I showed you my screen, you'd understand. Actually, let me just show you. It's like this. Can't see anything here, but I can see everything here, everything here. Ready? Look at this. Flexing with my keyboard. This is months of training. Oops. Oops. Not bad, bruh. Not bad. I think you should reposition your keyboard cam under your face cam and flip it 180 degrees so it actually looks like you're typing. What do you mean? Let's see, if you, I think you should reposition your keyboard cam under your face cam and flip it 180 degrees so it actually looks like you're typing. Get the keyboard cam capture, put it under my face cam so then you can actually see the keys typing. And rotate the capture 180 like an OBS dude. Yeah, I get what you mean. I get what you mean. Do you really want to see that though? Like, let me think. It would look funny. Let me move this a little bit. Oh, that's not gonna stable. It's not stable. How about that? 2 keyboards, cams. That's not bad, right? That angle is nice. But I don't think you got what I was saying, bro. Yeah, I didn't get it. I don't get the 180 degree flip. Do you mean like it's... Because if I do a 180 flip, you're telling me it's going to be upside down. It's like your arms are coming out of your face cam. And don't you mean... Yeah, I know not my keyboard. I know what you mean. Don't you mean that 90 degree flip? Yeah. Savasco gets you though. Stream chatting from across borders. Let me see. Let me put this back up. Get it straight. Okay. And then see what you mean then. Okay, I see what you mean, but the problem is like I'm not facing directly straight though, unless I'm actually looking at the camera like this. Unless I'm looking at the camera like this and typing. That'd be funny actually. I get you now. So Let me do that, why not? But still can work. Let me copy and paste a new frame. Okay. And then flip 180. Sure. And then I have my hand. Let's copy. And we paste. I mean, it kind of works. That's funny. If damn, 5 words per minute. I think I just moved myself down a level. Inomem. Night. Okay. I'm gonna just duplicate that scene, put it somewhere else. Delete. Okay, it's just in a different scene. Alright. No need. Let's go. Back to work. Back to work. Mahali Asma. Hi David, how long did it take you to learn Ngram? I got the glove 82. What switches do you have? Well, I think I put it in the description. Oh wait, no I didn't. The switches. The switches that I have are the red switches. I should put that in the description for the next stream. But yeah, they're the red switches. I can't take them off now, but you can kind of see a little bit of red peeking through. Maybe. Whoops. Wait. Yeah, a little bit of red peeking through there. The 35 grand. I think not the red pros. Oh, okay. The 35 grams are the red pros, so I got the 50 gram one. I feel no difference, or like I don't feel like it's heavier. I feel like this is even lighter than all the other keyboards that I've had in terms of clicking the buttons. I'm guessing, 35 will be way, I guess more sensitive. But yeah. And in regards to how long it took me to learn Glorious Ngramma, it took me maybe about 3 months on and off. I would say during the first semester of uni, I got it maybe second week in, and ever since then I had just been doing like monkey type problems using the code mode ever since then, and it's just how I've developed the skill there. And then these streams also help because I'm kind of enforced to use the keyboard. Basically, ever since I started streaming, I've been using this keyboard daily. And the shortcuts learning and stuff, once you know them, it's pretty good. Learning the shortcuts of like navigating the screen or copy and pasting. Like copy and pasting was even hard when I first started this. Like if you look at the first 2 streams, copy and pasting was hard for me, right? But then you pick it up. And yeah, so like how do you learn the layout too? Yeah, monkey type pretty much, just practicing the system 1 thinking, the muscle memory thinking. And this is alongside me still typing on a normal keyboard on my Mac. So what are the reasons for switching from a traditional keyboard? Basically, from one video that I watched called so it's from Code to the Moon. Do you use QWERTY on your Mac? Yes, I do. So I still use QWERTY on this as well, right? So I still use QWERTY on the Glove 80s. But anyway, Code to the Moon had this single video that convinced me to switch away from a traditional keyboard. This video, I tried so many keyboards, and you can see he features the Glove 80 in it. Yeah, the fact that you use your laptop a lot makes you shy away from other layouts. That's fair. I have a friend from uni that I also met, who's like pretty nerdy as well. Like he uses Vim and stuff. I pretty much convinced him to also get a keyboard, like an ergonomic keyboard, but he got the Moonlander, I think he got the Moonlander is what it's called. No, he didn't get the Moonlander, he got the Voyager. I believe. Yeah, he got this. Which he's liking, it's kind of more low profile than this. But yeah, he's liking it, but it's a lot of customization from what he's told me. And but we all still use QWERTY as well. So none of us are like Dvorak or Colemac yet, but in future, maybe, most likely. But yeah, the main reason for switching to the traditional keyboard was from this video who talked about ergonomic keyboards and the ones he's tried. And yeah, that's what convinced me. I mean, you know, the other thing is I'm going to be coding all my life, most of my life, I think. So I reckon investing in a good keyboard that prevents strain on the arms, hands, is going to be good. And it's also just rethinking the keyboard. Because, you know, I think he's mentioned it in that video, but the keyboards that we currently have are staggered, right? Staggered keys. Whereas these are like columnar keys, because it's all just ordered or like organized in columns. And apparently, you know, the key layout that we currently have is adapted from the typewriter. And the typewriter had these staggered layouts just to fit the mechanics of the insides of the typewriter. And then it's just stayed like this ever since, I guess. And everyone's just been doing it this way ever since. And, you know, the idea is using a keyboard like this, you twist your arm a little too much. So in this position it's a little bit bad for the hands and arms. And then that's why we opt for the ergonomics of these types of keyboards. That's all I can say to that, but this video explains it a lot better than I have. But, you know, like, don't feel bad if you don't have one. God, that Voyager looks nice, but 365 USD got me dead. Yeah, it's not a cheap hobby, that's the thing. There's a risk to watching this video because you're gonna get convinced to get one after you watch it. And I bought into it. What can I say? You know, I feel like the thing is, though, the target audience is programmers who type a lot, who maybe use Vim, and yeah, I think that's pretty much all I can say to that. I think I fit that description somewhat. I think, you know, this video alone, I think convinced me, but I knew about ergo keyboards before that a little bit from the Primogen, because he was using one, and then he was using Vim, so I wanted to learn Vim, and from learning Vim, he's like, you know, he shows his keyboard, and his keyboard's an ergo keyboard and looks something similar to this Kinesis keyboard, I think. And then, you know, he's made a review on this keyboard specifically, and he said it's that it's bad, that it's worse than the Kinesis, but I haven't tried, so I wouldn't know. But I think this suits me because I'm not really that much of a keyboard enthusiast, despite having spent $600 on these. But yeah. Also, this is one video, but actually this was the first video from Code to the Moon that I watched. Keys to a Dream software development setup. I honestly thought Keys to a Dream software development setup was like philosophies and not literally keys on a keyboard. So when I put this video in my watch later list, I actually didn't think it'd just be about a keyboard. And then it got me actually thinking about the keyboards. So yeah, Burr 600, yeah. I'm pretty sure it's yeah, a little higher than that also. But yeah. I'll give the video a watch though. Yeah. Watch it. Watch it. Just don't get bored into it. Make your own thinking, you know. Have your own critical thoughts on what you think about it, but it convinced me. That's all I can say to that. Okay, back to work. Alihan, nice to see you again. What's up? Well, I'll tell you what's up. I am studying this, and it's getting pretty difficult. I'm gonna take a break in a short moment, and come back to this after that. But I'm gonna finish this 3 minutes and then dip for like a break, a short break, and then I'll come back to get that shit understood. But yeah, I'm studying now. If you've followed the stream throughout today, it's pretty much just been study. Fundamental arithmetic? Yup. Now I'm just looking at discussion posts. Actually, I gotta be right back now, so give me like 10 minutes. Alhan says, by the way, we have the same mice. I'm not surprised. This is a pretty good mice. Pretty famous. Why do you have this mice, huh? Internal gamer? Internally a gamer? We are officially in the stage of Leetcode now. So we'll see. Okay, implement the LRU cache class. Simple recency-based policies least recently used. Discards least recently used items first. This algorithm requires keeping track of what was used and when, which is cumbersome. It requires age bits for cache lines. It tracks the least recently used cache line based on them. When a cache line is used, the age of the other cache lines change. LRU is a family of caching algorithms which includes 2Q by Theodore Johnson and Dennis Shasha, and LRUK by Pat O'Neill, blah blah blah. The access sequence for the example ABCDEDF. A, B, C, D, least recently used gets overwritten. E, D, when A, B, C, D is installed in the blocks with sequence numbers, increment 1 for each new access, and E is accessed. It is a miss but must be installed in a block. With the LRU algorithm, E will replace A because A has the lowest rank. In the next to last step, D is accessed and the sequence number is updated. F is an access replacing B, which has the lowest rank, B1. Time-wise. Yeah, that's fine. Okay. Design a data structure that follows the constraints of least recently used. Implement the LRU cache class. LRU cache int capacity, initialize the LRU cache with positive size capacity. Int get int key, return the value of the key if the key exists, otherwise return -1. Okay. Alright, give me a second. I'm gonna have to grab some. Okay, hello UK. Int capacity initializes with positive size capacity. Int get int key, return the value of the key if the key exists, otherwise return -1. Void put key value, update the value of the key if the key exists. Otherwise, add the key's value pair to the cache if the number of keys exceeds the capacity for evict the last recently used key. Get input must be O of 1. Average time complexity. Interesting.
Then we'll return the value that it corresponds to. If it doesn't exist, the default value we want to return is -1. And if we're getting values, we also need to be able to put values into the cache. We're putting them in based on key value pairs, and there's a lot of edge cases, and they explain a bit of them to us. If the key already exists in the cache, then we just want to update the value. If it doesn't already exist, then we're inserting it for the first time so we can put that key value pair into the cache. And remember, this does have a fixed size capacity, so if we ever exceed the capacity, then we have to evict the least recently used. So that's why this is called the LRU cache problem. And it also makes sense, right? If there's a key that we're not really using, then that's the one that we're going to take out of the cache. And this is actually pretty similar to how browsers work. So for example, if you're using Chrome and web browsers have caches, if there are values that we're not really using in that cache, then of course we can remove them. Let's also try to solve this the most efficient way, which is each of these operations, get and put, are going to be constant time operations. And it's going to be kind of tricky, but it's definitely possible. So let's just look at the first example. So the input is 2, so that's something that we need to kind of remember, right? The capacity is 2 in this case. And the next operation is put, so we're putting a pair of 1, 1, key 1, value 1. And we're going to keep these kind of in order, right? Because we want to remove the least recently used, so we got to kind of remember in what order are we adding these values in. The next one is another put operation, and we're putting 2, 2. Of course, for these first 3 operations, we're not really returning anything, so the output is going to be null. So next we're actually doing a get operation, and we want to get the value that has a key of 1. And remember, we're trying to do this as fast as possible. We're trying to do each operation in constant time. So how can we know instantly what the value is when the key is 1? Well, the easiest way to do that would be with a hash map, right? So we're going to use a hash map to instantly look up the value of every key. We can of course do this in constant time, and we know that the size of this hash map doesn't need to exceed our capacity, so we can have only 2 values here, right? So for the key value, we can use the same value that we use for each of our nodes. And for the value, we could also do the same thing. We could use the same value that we use in our nodes, but I'm going to show you why it's going to be a little bit better for us instead to have the value be a pointer to the node itself. And we can do the same thing with the second node that we inserted as well. So for key value 2, we're going to point at this node. So now finally, when we call this get and we ask for the key 1, we're going to return the value 1 that's over here, which is exactly what the output tells us is correct. So since we just used the get operation to get this one, we went to our key, then we found this value, and then we returned that value, that makes this the most recently used value, and this is the least recently used value now. So I'm going to keep track of the most recent and least recent by having a left and right pointers, right? So this left side is going to be the least recently used, and the right over here is going to be the most recent. So therefore, we're basically going to be swapping these 2 nodes, right? And so this portion of the problem is starting to keep the ordering of these. It looks like we're going to need a linked list. And not only a linked list, but a double linked list. Because remember, we can easily look up where these values are, but if we want to also reorder them quickly by for example, every time we use a get operation, we want to take this value and then move it over here because it was the most recent. And so now we're going to reorder the 2 nodes. So now this is the least recently used and this is the most recently used. And since this is a doubly linked list, we need the pointers to be connected. Of course, the hash map won't really need to be updated because these are pointers. They're already going to be pointing to the correct ones, and I'm not going to show that. And now we can get to the most interesting operation, the third put. So we're putting a third value, key value, 3, 3. And since 3 is greater than our capacity of 2, then we're going to have to remove the least recently used value, and convenient for us, we know exactly what that value is. So first, we're going to end up updating these pointers to make the least recently used 1, 1 and get rid of this. And of course, we want to replace that 2 since we know it's the
Let's see, put, what am I putting? First, we have to check if we're going to go greater than our capacity. Maybe len of hash map. Len of hash map, maybe, is len O of n it's O of 1. Good. That's what I expect. It's O of 1. If we're going to be greater than the capacity, LRU is going to be the left recently used node, which is going to get deleted. So we delete the left recently used. And then we continue with LRU, and then we continue with the rest of the
Least recently used. We want to replace it with the new key 3, and now we also want to update that.
Oh, right. So the hash map gets updated.
Pointer, we want it to point at the new node. And since the new node 3.3 is the most recent, we're going to put it over here. 3.3. And the pointer is going to point here.
Most recent, well, we're going to have to go here. Add so the current MRU, would these be self? I think so. MRU is going to equal to list node three. Next, none, brev, self, MRU. Self key key is int, value is int, next is list node, which is equal to I don't know how to do this, is equal to none. No, that's not how you do it. How to set default argument with value with typing in Python. Okay. It was what I thought it was. Add MRU and that's it.
This pointer is going to point here, and there's going to be a double link between them. So this is basically the main idea. We're going to keep track of a capacity. We're going to have a double linked list. We're going to have a hash map where the key of the hash map is going to be the same key that we get from the input, and the value is going to be a pointer to the nodes. And each node is going to look something like this. And it's going to have two pointers, remember? So it's going to have a previous pointer and a next pointer. And don't forget about this right and this left. These are also going to be nodes because we want to have pointers. We want to be able to instantly know what's the least recently used and what's the most recently used. So these are going to be dummy nodes pretty much.
Oh, they're going to be dummy nodes, okay. If they're going to be dummy nodes, then we're going to have to change this a little bit as well. I should just make the default 0. So self.mru is also a list node, and when you deal with list nodes, there's an assumption there. Guess can we make that assumption? Probably not. Then what? Else what? Self.liu.next is equal to none. Would that be right? Let me think. Are we guaranteed this will not be none? I suppose if the prev is equal to self.liu, then that's guaranteed to have something. So you don't need this. And you add an MIU. Sure. And then for the get, I'm pretty sure I'm mostly good here. Wait, so self MIU. Yeah, no, I'm not mostly good. So add MIU, we would need prev equal to a new list node with next is and prev is is that right? Self MIU prev. I think that's right, and the get would be interesting. That's the node value. That's the node. We'd need to return node of 1 anyway. But before we even do that, we need I need to do something. Let's see, you got node from the hash map. You point to the list node. That's the list node you get data from. You update that list node to the front. So you have to take it out of its current position and then move it to the front. Take out of list position by, so you got node dot next and you got previous. So node prev dot next. The previous node's next node is going to equal to node dot next node dot next. Alright, and then node dot node dot next dot prev is going to equal to node dot prev. Fact of the matter is, do I need to watch out for any overwrites here? Node prev next. And then move to MIU. Node, so move to most recently used, self.miu.prev is equal to node, and node has to equal to node's next value has to be equal to MIU now. I don't know. It's definitely probably not going to work. Alright, so node next is self MIU. Key error hash map. Is it because we add the MIU but we never add the hash map? Instead of value we point it to This node object is not subscriptable, obviously. Key error 3. Oh, we don't want to delete the key. I suppose, you know, I could just have it before the hash map. Yeah, why not just put it before the hash map? Before the deletion, I mean. Self LRU next. Control backtick. Control colon. Control colon. Colon. Control colon. Control colon. It's colon here. I see. Control colon. Key error 0. Assuming could start off with maybe I want to print stuff. Control V. Run this. So put 1, put 2, get 1, put 3, get 2. See, is this right? I think there might be something awry here, so put 1 1. If we put 1 1, we're going to go Maybe I also write something about print delete LRU and print add MIU. Just run this. Add MIU, delete LRU is the first time we were going to delete LRU because we were, expanding. So delete LRU, next dot key was 0, which is not what I expect for when we add something into the list. So
getting into the code, remember we're gonna need a node. So before we even write this LRU cache class, let's make another class for that node that we're gonna use. And remember, each node is gonna have a key value pair. So we're gonna get those. We're gonna initialize those. And we're also gonna have 2 pointers, one for the previous node and one for the next node, and they're both going to initially be set to null. Now when we actually get into the LRU class, we know that the capacity needs to be stored because we want to know if we ever go over that capacity. We also need a hash map, and I'm going to call that our cache. And remember, this is going to map the key to nodes. And before we even have any values in our cache, we want to have a couple dummy pointers, a couple dummy nodes, which tell us what are the most recent and least recent values that we added. So we can just initialize these to 0 for the default values, so 0, 0. And initially we want these nodes to be connected to each other because if we're putting a new node, we want to put it in the middle between left and right. And we can do that with some pointer stuff. So left.next is going to be right, and right.previous is going to be left. And remember, left is going to help us find the least recently used, and right is going to be most recent. So now let's start with our get function because it's mostly straightforward. If the key exists, so if the key is in our cache, then we can return that value, right? So we can return self.cache of key. Now this tells us the node, remember, because each key is mapped to a node. So to get the value, we can just do .val. And of course, if it doesn't exist, they wanted us to just return -1. Now the only thing we're forgetting with this get is that every time we get a value, we want to update it to the most recent. So to help us with this part, I'm actually going to write a couple helper functions. So I'm going to write a remove and insert helper function. And these helper functions are going to be applied to our linked list. So we're going to pass in the node that we want to remove from our doubly linked list. And I'm also going to write a function to insert into our linked list. And when we insert, we're going to insert at right. And the remove is just going to remove from the list. So these are basically going to be pointer functions. We're going to be manipulating some pointers from our left, right, and doing some stuff, so I'm not even going to worry about that. All I know is that we have a helper function that can remove any node from our list, and a helper function that can insert any node at the rightmost position of our linked list. So since we're getting, what we want to do to our list is take this node, self.cache of key, and remove it from our list. And after we remove it, then we want to reinsert it at the rightmost position. So we can just do self. And looking at this, get isn't so bad as long as we fill out these two helper functions for us. So now when we actually look at our
I see. Node self hash map key. Doesn't matter, that's good, I think.
put function, let's remember that if we have a key that's already in our cache, that means that a node already exists in our list with that same key value. So before we can insert this new key value pair, we want to remove from our list. So we can get that node by getting our cache and using the key value. So these helper functions are definitely coming in handy for us. So now we can create a new node with this key value pair. So node key value.
Hold on, so
and looking at this, get isn't so bad as long as we fill out these two helper functions for us. So now when we actually look at our put function, let's remember that if we have a key that's already in our cache, that means that a node already exists in our list with that same key value. So before we can insert this new key value pair, we want to remove from our list. So we can get that node by getting our cache and using the key value. So these helper functions are definitely coming in handy for us. So now we can create a new node with this key value pair. So node key value, and we can put that in our hash map. So now our hash map has a pointer to this node, but remember that's not enough. We also have a doubly linked list, so we need to take this node and insert it into our list. So insert and just pass in the node, which is cache of the key value. So the node is stored here, and we pass that node into our insert function.
this is way better designed than what I did.
Okay, so we just inserted a new value, but remember we have a capacity to worry about. So every time we insert a value, we gotta check, does the length of our cache now exceed the capacity? If it does, this is the part where we're gonna remove and delete or evict the least recently used. So we're going to remove it from the list, the linked list, and delete the LRU from the cache or the hash map. So how do we actually find the node for the LRU? Well, this is why we have our left and right pointers. Remember, the left pointer is all the way at the left, and it's going to tell us what the least recently used was. So left.next is always going to be the least recently used. And so first, we're going to remove it from our linked list by just passing in the node. And we're also going to delete it from our hash map. So self.cache. And we want the key of this node, which is actually stored in the node itself. This is why we didn't only store the keys. So left.next is always going to be the least recently used. And so first, we're going to remove it from our linked list by just passing in the node. And we're also going to delete it from our hash map. So self.cache. And we want the key of this node, which is actually stored. in the node itself. This is why we didn't only store the value, we also store the key in our node class. So we don't have to return anything in put, but we do now have to fill out these two helper functions, remove and insert. So if you have 3 nodes and you want to remove the middle node, what do? Well, you take this pointer and move it over here, and you take this pointer and move it over here. So this stuff is no longer relevant, and we have removed the middle node. This is going to be referred to as our previous node. This is referred to as our next node. So when we're writing this function, node is going to be the middle node, so we want to get the previous and next nodes of node. So we can just put the pointer, so node.previous, node.next. All we want to do is say that previous.next should be updated and next.previous should be updated. These are the 2 pointers of the next and previous nodes. So previous.next should be next. Next.previous should be previous. So now node is
node prev next, node prev no longer in between previous and next. The last thing we need to do is fill out our insert function, which what we want it to do is insert a node at the rightmost position, right before our right pointer. So let's say this is our right pointer. We want to insert right here, and this is going to be our previous pointer. So when we have our new
node that we're trying to insert, what we want to do is take this pointer and reassign it to that, this pointer, and reassign it over here. And we also want this node to be connected to its neighbors. So we're going to have the next pointer over here and the previous pointer to be here. So in this case, our
Yep, so insert isn't entirely what I did here. Let me think. So node next is equal to self MRU. Node prev is equal to self MRU prev. MRU is going to equal to have a prev. It's going to be updated to, so MIU has a prev and a next, but the next doesn't matter. But the prev is just going to be node, and then MIU's prev, so just before next is going to be equal to node. 1, 2, 3, 4. So it's 1 pointing there. What about the previous? Oh, it's just, yeah, okay, I think that's right.
previous and next pointers we can get by using our rightmost pointer. So self.right.previous and self.right. Now we want both previous and next to point to node, so we can do that like this. Previous.next is going to be equal to next.previous, which is going to be equal to node. They're both pointing at node. Node has been inserted in the middle of them, and node.next and node.previous also need to be assigned to next and previous. So this is quite a lot of code, about 44 lines with some space and comments in between, but this is how you get the most optimal solution for this problem. And of course I had a bug, so I misspelled something. I'm really hoping that's the only bug here, because I do not want to search for a bug in these lines of code. Okay, so we got it to pass, so I hope this was helpful.
Alright, that's good.
If you enjoyed, please like and subscribe, and I'll hopefully see you pretty soon.
What? That was a runtime error. Oh no, no runtime error. Okay, that's good. Man, it's crazy. It's crazy. Can I create one called 146 LRU cache .py, and we're just going to copy and paste. Nah man, don't make me rewrite all this. Didn't need to format the code, alright. But code editor, WordWrap, Vim, standard. Okay, if I can just copy this now, that'd be great. List node not defined. God, what is even this? Oh my god. Is that right? Man, this is like so annoying. It's also because, yeah, okay, I'm just gonna write quit, git add, git status, git dash m. I'm fine. Control C. Oh. Let's try run this. Bah, that's so bad. Done. Alright, done. Done with that question. Ooh, hello KFC. Hello. Thanks for joining in, man. I'm about to eat dinner. I'm pretty cooked now. So, ciao for now. I'll come back after dinner. So, see you soon. Okay. Alright, let's just read up on this. Boxes have an inner display type and an outer display type. Generally can set various values for the display type using the display property, which can have various values. Outer display type. If a box has an outer display type of block, then the box will break into a new line. The width and the height properties are respected. Padding, margin and border will cause other elements to push away from the box. If width is not specified, the box will extend in the inline direction to fill the space available in its container. In most cases, the box will become as wide as its container, filling up 100% of the space available. Some HTML elements such as h1p and block use block as their outer display type by default. If a block has an outer display type of inline, then the box will not break onto a new line. The width and height properties will not apply. Top and bottom padding, margins and borders will apply but will not cause other inline boxes to move away from the box. Left and right padding, margins and borders will apply and will cause other inline boxes to move away from the box. Some HTML elements such as a, span, em and strong use inline in their outer display type. Inner display type. Boxes also have an inner display type which dictates how elements inside that box are laid out. Blocks an inline layout in the default way things have made behave on the web. As a block box, the paragraph starts on a new line and extends the entire available width. A list which is laid out using display flex. This establishes flex layout with the children of the container, which are flex items. The list itself is a block box. Like the paragraph, expands to the full container width and breaks into a new line. A block level paragraph, inside which are two span elements. These elements would normally be inline, however one of the elements has a class of block, which gets set to display block. Yeah, that makes sense. In the next example, we can see how inline elements behave. The span elements in the first paragraph are inline by default. Hey, what are you studying? KFC says. Right now, I'm doing the Odin Project and learning about the box model. So, reading up on one of the assignments in this, the MDN's lesson on the box model. This page. In the example, we see how inline elements behave. The span elements in the first paragraph are inline by default, so do not force line breaks. Let's see, so the next example, see how inline elements behave. Dot inline, display inline. and so do not force line breaks. Alright, let me stand up. Okay, in the next example, we can see how inline elements behave. Span elements in the first paragraph are inline by default, so do not force line breaks. Sure. Span list has border 2 solid picks, 2 picks solid blue, 2 picks solid Rebecca purple, inline flex, list style none, padding, inline display inline. You can change display inline to display block or display inline flex to display flex. KFC says, you live in Australia? Yeah, I do. Yeah, so it's dark out right now. So inline flex versus flex, right? So flex. Ooh. Whoops, that is not what I intended to type. Fair enough, okay, inline flex, that's how it works. Display block. The key thing to remember is changing the value of the display property can change whether other display type of box is block or inline. This changes the way it displays alongside other elements in the layout. What is the CSS box model? The CSS box model as a whole applies to block boxes and defines how the different parts of a box, margin, border, padding, and content work together to create a box that can see on a page. Inline boxes use just some of the behavior defined in the box model. To add complexity, there is standard and an alternative box model. By default, browsers use the standard box model and an alternate box model, so parts of a box. Making up a block box in CSS, we have the content box, the area in which your content is displayed, size it using properties like inline size and block size or width and height. Sure. Padding box, the padding sits outside the content as white space. Size it using padding and related properties. Border box, the border box wraps the content and any padding. Size it using border and related properties. Margin is the outer layer wrapping the content. Size it using margin and related properties. The below diagram shows these 3 layers. The standard CSS box model, this is the standard box model if you set inline size and block size or width and height property values. On a box, these values define the inline size and block size. Width and height in horizontal languages. In the standard box model, if you set inline size and block size values on a box, these values define the inline size and block size of the content box. Width and height. Any padding and borders are then added to those dimensions to get the total size taken up by the box. Padding 25px, border 5px block back, border 5px solid black. The actual space taken up by the box will be 410 pixels, which is because of the 25 padding and the 5 border, the margin 10, and 210 pixels high. Fair enough. Note the margin is not counted. Sure, it affects the total space that the box will take up on the page, but only the space outside the box. The box's area stops at the border, it does not extend into the margin. KFC says, which year are you in college? Right now I am in 4th year, you could say. Although technically I graduated last year. So I finished my masters. I finished my bachelor's and now I'm doing my masters. So I'm in my 1st year of masters. Gonna finish next year, late next year. So it'll be in December next year, where I'll be done with my masters by then. So, yep. Right now I'm just trying to skill up, get as much content as I can. I mean, I'm gonna be learning throughout my life, but you know, this is where it focuses, hones down, and I'll make my money next year or after next year. When I actually get a job. Okay. The alternative CSS box model. In the alternative CSS box model, any width is the width of the visible box on the page. The content area width is that width minus the width of the padding and the border. See below image, no need to add up the border and padding to get the real size of the box. To turn on the alternative model, for an element, set box sizing to border box. If we assume the box has the same CSS as above, now the actual space taken up by the box will be 350 pixels in the inline direction, 150 pixels in the block direction. To use the alternative box model for all the elements, which is a common choice among developers, set the box sizing property on the HTML element and set all other elements to inherit that value. HTML box sizing to border box, and box sizing is to inherit. To understand the underlying idea, you can read the CSS Tricks article on box sizing. Play with box models. In the example below, you can see 2 boxes, both have a class of box, which gives them the same width, height, margin, border, and padding. The only difference is that the second box has set to use the alternative box model. Alternate. Valid. You know, I can also Command-Shift-I here, just to Control Shift C this box and just see the differences. I understand, you know, like, this is epic. I understand this. Okay. Use browser dev tools to view the box model. You can understand the box model far easier. It is to inspect an element in Firefox dev tools. You can see the size of the element plus the margin, padding, and border. Inspecting an element in this way is a great way to find out if the box is really the size you think it is. I mean, yeah, let's go back here. Whoops. So, just look at this. $300, $150, $40, $40 versus this alternative, which is $2, $10, $60, $40, $40, and the 5 is totals to 90, which takes it from 300 width. Is that right? Yeah, 300 width and then 150 height. Yeah, makes sense. Okay, and then margin, padding, and borders. You've already seen the margin, padding, and border properties at work in the example above. The properties used in the example are shorthands and allow you to set all 4 sides of the box at once. These shorthands also have equivalent longhand properties which allow control over the different sides of the box individually. Let's explore these properties in more detail. Margin has invisible space around your box, but it pushes other elements away from the box. Margins can have positive or negative values. Setting a negative margin on one side of your box can cause it to overlap other things on the page. Whether we're using the standard or alternative box model, the margin is always added after the size of the visible box has been calculated. We can control all margins of an element at once using the margin property, or each side individually using the equivalent longhand properties. Margin top, right, bottom, or left. In the example below, try changing the margin values to see how the box is pushed around due to the margin creating or removing space. If it is a negative margin between this element and the containing element. Interactive editor, margin top, negative 40, positive 40. Margin bottom, margin left. Margin right, maybe we'll just take it to 30px. It's pretty good, yeah. Margin collapsing. Depending on whether 2 elements whose margins touch have positive or negative margins, the results will be different. 2 positive margins will contribute to becoming 1 margin. Its sizes will equal to the largest individual margin. 2 negative margins will collapse, and the smallest further from 0. Value will be used. If one margin is negative, its value will be subtracted from the total. In the example below, we have 2 paragraphs. The top paragraph has a margin bottom of 50 pixels and the other has a margin top of 30 pixels. The margins have collapsed together, so the actual margin between the boxes is 50 and not the total of the 2 margins. You can test this by setting the margin top of paragraph 2 to 0. The visible margin between the 2 paragraphs will not change. It retains the 50 pixels set in the margin top of paragraph 1. If you set it to negative 10, you will see the overall margin becomes 40px. Okay, so let's test this. You can test this by setting margin top of paragraph 2 to 0. The visible margin between the two will not change. It retains the 50 pixels. If you set it to -10, you will see the overall margin becomes 40 pixels. It subtracts from the 50. Damn. That's cool. But it's almost unintuitive. But maybe it is intuitive. A number of rules dictate when margins do and do not collapse. For further information, see the detailed page on mastering margin collapse. The main thing to remember is that margin collapsing is a thing that happens if you're creating space with margins and don't get the space you expect. Borders. The border is drawn between the margin and the padding of a box. If you are using the standard box model, the size of the border is added to the width and height of the content box. If you're using the alternative box model, then the bigger the border is, the smaller the content box is, as the border takes up some of the space available, width and height of the element box. For styling borders, there are a large number of properties. There are 4 borders, and each border has a style, width, and color that we might want to manipulate. If you set the width, style, or color of all 4 borders at once using the border property. Oh, okay. You can set the properties of each sides individually. You can set the width, width, style, or color of all sides. Set the width, style, or color of a single side. If you want more granular on longhand properties. In the example below, we have used various shorthands and longhands to create borders. Play around with these different properties to check that you understand how they work. The MDN pages for the border properties give you information about the different available border styles. Dotted line, solid, double, I see, black, green, border, so box, could have thick box, bottom color hot pink, border top style dotted. Yeah, fair enough. And then border 1 pix solid. On the leftover border. Yeah, I see. And then you got a container wrapped around the box. So if I actually go and just check this out a little bit. Is that the border? That's the container. Div.box. Just look at the container here. So padding, border, content, margin. Okay. I'm good. I'm good. I'm good. Padding sits between the border and the content area and is used to push the content away from the border. Unlike margins, you cannot have a negative padding. Any background applied to your element will display behind the padding. The padding property controls the padding of all sides of an element. To control each side individually, use these longhand properties. In the example below, you can change the values of the padding on the class. Dot box to see that this changes where the text begins in relation to the box. You can also change the padding on the class container. To create space between the container and the box, you can change the padding on any element to create space between its border and wherever it's inside the element. Padding top. Let's do just 10. I can already see, like, you know, what this really means for us. Okay, 20. And each of these could be changed to whatever we want. Of the padding, of the content. Let's see this again. Yeah, makes sense. I think that makes sense because, you know, padding top is 0, no padding on the top. Padding right is smaller than the padding at the left, and the padding at the bottom is 40 pixels, which is also bigger than the padding on the right. So that makes sense to me. The box model and inline boxes. Wow. All of the above. Okay, KFC. You prefer article or tutorial for theory stuff? Depends on what you mean by article. If you count this as an article, I do prefer this over... Ooh, I guess I prefer this now over doing a tutorial. I mean, this is technically also a tutorial, I suppose, because, you know, I'm interacting with stuff, you know, in an editor and seeing it. So maybe this is classified more as a tutorial. Maybe I do like tutorials more. But I guess if you're talking about, say, an article that doesn't have stuff like interactive things, then it does become a little harder to consolidate knowledge. I definitely agree. So maybe I do prefer tutorials, actually. So I take that back, what I said originally. Here. The box model and inline boxes. All of the above fully applies to block boxes. Some of the properties can apply to inline boxes too, such as those created by a span element. In the example below, we have span inside a paragraph. By the way, this specific inline thing I should take a particular note on, because I'm gonna at some point be creating tags like what Todoist has, or like regex on the actual lines of the task, right? So for example, hello world, and then I type an @ symbol, or say I type P1 and it auto highlights, right? That's an inline, I think an inline div of some sort, right? Surely I can see. More tools. Web dev tools. Margin 0, border 0, padding 4, right? The padding 4 is how much you use to, I guess, pad around that number, that word. And then if I get rid of it, you know, there is still some spaces that do move. But this is what I expect. This is what I want to recreate, you know? At some point. So I gotta take a specific note of what span does here, because span in HTML. Just want to quickly look at what span is. To be honest, look, this is an article that I might not want just because it's made by someone like HubSpot. It's a company. It's a company making content for the sake of bettering their SEO. Not my type of stuff, but companies do it, and it contributes to more noise than good. Anyway, let me sit down for a second. Okay. The box model inline boxes, if all of the above fully applies to block boxes, some of the properties can apply to inline boxes too. Those created by a span element in the span below, we have span inside a paragraph. We applied width, height, margin, border, and padding. You can see that the width and height are ignored. The top and bottom margin, padding, and border are respected, but don't change the relationship of other content in your inline box. The padding and border overall overlap other words in the paragraph. This left and right padding margins and borders move other content away from the box. Margin 20 pixels. $80 pixels. 20 pixels. I am a paragraph, and this is a span. Inside that paragraph, a span is the inline element and does not respect width and height. So margin it respects, padding it respects, width doesn't do anything, height doesn't do anything, background color blue, border 2 pixel blue. I'm a paragraph and this is a span. Okay, using display inline block. Display inline block is a special value of display which provides a middle ground between inline and block. Use it if you don't want an item to break onto a new line, but do want it to respect width and height and avoid the overlapping seen above. An element with display inline block does a subset of the block things we already know about. The width and height properties are respected. Padding, margin, and border will cause other elements to be pushed away from the box. It does not, however, break onto a new line and will only become larger than its content if explicitly add width and height properties. In the next example, you will add display inline block to our span element. Try changing this to display block or removing the line completely to see the difference. Okay. Block versus inline block. I'm happy with that. Where this can be useful is when you want to give a link a larger hit area by adding padding. A is an inline element like span. You can use display inline block to allow padding to set on it, making it easier for a user to click the link. You see this fairly frequently in navigating bars. The navigation below is displayed in a row using flexbox, and we can have added padding to the A element as we want to be able to change the background color when the A is hovered. The padding appears to overlap the border. This is because the A is an inline element. Links list. Where is the... I don't see a flex box. Man. Just trying to think. Shall I do anything? Okay, let me understand this again. Man, this is so long. This specific, I'm so close to the end. Okay, when this can be useful is when you want to give a link a larger hit area by adding padding. You can display inline block to allow padding to be set on it, making it easier for a user to click the link. You see this fairly frequently in navigating bars. The navigation below is displayed in a row using flexbox, and we have added padding to a element as we want to be able to change the background when A is hovered. The padding appears to overlap the border on the unordered list element. This is because A is an inline element. Add display inline block to the rule with the linked list A selector, and you will see how it fixes this issue by causing the padding to be restricted by other elements. Interesting. Test your skills. You reached the end of the article, but if you remember the most important information, you can find some further tests to verify that you retain this information before you move on. Oh man. That's most of all you need to understand about the box model. You may want to return to this lesson in the future if you ever find yourself confused about how big boxes are in your layout. Look at how backgrounds and borders can be used to make your plan. Oh, hello, DJ. Keep on forgetting display inline block. That's alright. I'm good. The CSX tricks page has some further information about the margin property that you'll find useful, especially the section about auto and margin collapsing, containing things you'll want to know. Collapsing margins, negative margins. Good, okay, good. Sarah Cope. The margin property defines the outermost portion of the box model, creating space around an element outside of any defined borders. Margins are set using lengths, percentages, or the keyword auto, and it can have negative values. Here's an example. Jacob George. These are some fire tunes. I just put on lo-fi music. It's pretty fire. I do agree. Margins set using lengths, percentages, or the keyword auto. You can have negative values. Here's an example. Short end property and accepts up to 4 values. Oh, that's mad. I didn't know that was possible. That's why you could put 4 things on there. If fewer than 4 values are set, the missing values are assumed based on the ones that are defined. For example, the following 2 rule sets would get identical results. Oh, that's mad also, I didn't know that. Thus, if 1 value is defined, this sets all 4 margins to the same value. If 3 values are declared, it's margin top, left, right, bottom. Any of the individual margins can be declared using longhand, in which case you would define only 1 value per property. Auto and centering. Each of the margin properties can also accept the value of auto. The value of auto basically tells the browser to define the margin for you. In most cases, the value of auto will be equivalent to a value of 0, which is the initial value for each margin property, or else whatever space is available on that side of the element. However, auto is handy for horizontal centering. Horizontal centering. In the example, 2 things are done to center this element horizontally within the available space. The element is given a specified width, and the left and right margins is set to auto. Without the specified width, the auto values would essentially have no effect. Setting the left and right margins to 0, or else to whatever is available space inside the parent element. It could also be pointed out that auto is useful only for horizontal centering, and so using auto for top and bottom margins will not center an element vertically, which can be confusing for beginners. That's also mad. I'm going to save that. Collapsing margins. Vertical margins on different elements that touch each other, thus have no content, padding, or borders separating them. Will collapse, forming a single margin that is equal to the greater of the adjoint margins. This does not happen on horizontal margins, left and right. Only vertical top and bottom. Take the following. Example text. Left and right. Is that right? Left bottom, right top. Left and right. In this example, the HTML element is given a bottom margin of 20. That's not bottom margin, is it? Isn't that left margin? I mean right margin. Yeah, I think they made a mistake here, no? Regardless, I understand anyway. Oh man, I read it wrong. Margin left, margin bottom, margin right, margin top. So it is margin top first, then right, then bottom, then left. Top, right, bottom, left. It's like northeast, southwest. That's a good way to remember it, actually. North, east, south, and north. Yep, okay. Paragraph element, which immediately follows it in the source, has top margin set as 10. Common sense would seem to suggest the vertical margin thickness between the H2 and the paragraph would be a total of 30, but due to the margin collapse, the actual thickness ends up between 20 pixels. This is demonstrated in the embedded pen below. Sure. Although collapsed margins may seem unintuitive at first glance, they are actually useful for a few reasons. First, they prevent empty elements from adding extra usually undesired vertical margin space. Second, they allow for a more consistent approach to declaring universal margins across page elements. Ooh. Oh, my computer died. I have a laptop on the side. Oh my god. What the heck? My hand! My hand is frozen. That's not even working. Just gotta close it out. Reopen. I think that's working now. I see. Thanks for letting me know, Jacob. Oh, it's probably been frozen since you joined. I'm actually typing. Okay, let's see. So, second, they allow for more consistent approach to declaring universal margins across page elements. For example, heading commonly have vertical margin space and so do paragraphs. If margins then collapse, headings that follow paragraphs, or vice versa. Adam, Adam says, how are you able to sit and focus for long hours? Were you always studious as a kid? Good question. Let me think. I think I would say yes. I'd like to be studious as a kid. I think you could say I was in high school. But more recently, like, I've been able to sit down more. Like, I've had troubles with procrastination in the past as well, you know what I mean? But I've found it to be easier over the years. Just from, say, the ages of 18 to now, just about turning 23. So 4 years, 5 years almost. Actually, I'm not turning 23. I think I'm only turning 22. Yeah, I'm only turning 22. So 4 years of finding myself, getting to a point where I'm like dedicated to a craft and pretty much bought into it. So, you know, even doing this reading right now is tough, but I know there's a purpose behind it. I think that's what's driving me, especially with the other concept of doing hard things earlier in the day. So like as the first things in the day. That's why I always do Leetcode first. Or in this case today, it was study first before doing a Leetcode question and then doing this. You know, I'm trying to do the hardest things first as well. And then so when it comes to the 9th or 10th hour in the day, when I want to do something that's somewhat more exciting than the other two, you know, it's what drives me in the last few hours of the day. I think that's how I can explain it best. You know what I mean? So yeah, right now doing this is challenging, but it's also fun. And it also switches my brain's contexts from first learning about intro to maths earlier today that I did. What was it even called? We talked about, come on, recall. This was for cryptography and security, which is one subject. And it was an introduction to cryptography that I browsed over and then read in more detail the basic math section, which was related to the modulo, just getting some proofs there. So all that is still being processed in my head, and I'm gonna have to sleep through it to actually explain it in full. But there was that, and then earlier in the day also I finished off another lecture before the upcoming lecture today, which is also a hard thing to do first thing in the morning. But you know, doing the hard things first thing in the morning, I think makes it easier to do the more motivating things later in the day. Very interesting. Thanks for the answer. I've asked people about this. Their answer is usually not complicated, but it makes sense that you've been studious since 18. Yeah. Also, you might hear my parents now. They're at home. But wait, what do you mean? So, very interesting. Thanks for the answer. I've asked people about this. the answer is usually not complicated, but it makes sense that you've been studious since 18. What do you mean? Are you saying my answer was complicated? Maybe. Maybe. Okay. Shaikh Fazaludin. Sorry. Shaikh Fazaludin. Hi, can you tell me more about the Odin Project? Sure. You know, so the Odin Project is a way to learn web development from scratch. I'm talking from setting up your code editor in VS Code all the way to React and all that React can bring and whatever you want. I would say, you know, I'm learning the Odin Project because I want to understand HTML and CSS better, and I think that's going to be better for me in the long run, as well as better for me in the short term when I'm building this app that I'm building right now, which I need just basic HTML and CSS knowledge to actually not rely and crutch on Tailwind CSS, for example, and Tailwind UI, or like these UI libraries, for example. I don't want to depend on those because I want to make my own. Adam says, no, your answer wasn't complicated. I was just saying I usually overcomplicate how to be productive. Sorry for the confusion. I see. That's all good. That's all good. But this is the app that I'm building also. And, you know, I've used some components from Tailwind UI, which is like a UI library, or not really a UI library, but it's a collection of UI elements that you can just copy and paste. Right. So I used some UI components from here, but I want to end up building my own stuff. You know, that looks like stuff like this. Using Tailwind CSS, but by first understanding CSS well and understanding HTML well. And you know, the app, I guess I can show you exactly what elements I used. Literally, navbar from Tailwind UI. You know, you still have the Tailwind icon here, so you can tell from there. And same thing with the calendar here, also taken from Tailwind UI, except, you know, I've made my own changes in the back end, not in the back, just in the front end, where you can actually modify, change these dates, and whatnot. But you know, it's still building. I'm still trying to understand HTML and CSS using the Odin project, you know. And with the Odin project, if I go to the dashboard, you know, there's a foundations that I'm going through right now, 54% done. And I also, I think, went halfway through one of the full stack JavaScripts, or a third way through for the React side of things, just to, you know, learn what I need to learn to get this app going, basically. So yeah, it'll get better. It'll get better. But the other thing that I really want to get up to in this foundations course from the Odin project is flex boxes. That's one thing that I've never fully understood. So once I've understood this, like, I'm pretty much good to start creating stuff. From scratch, all by myself, hopefully. And then JavaScript basics. I feel like I already know a lot of this, just from previous experience, but I will go through them anyway. Just to have a holistic understanding. At the end of the day. JB Does It says, I just learn things as I need them. I went through tutorial hell learning stuff I didn't have a use for, and then I forgot it. Fair enough. Fair enough. Fazal says, great, have you finished your graduation or still a student? I graduated from bachelor's already. So I've done my 3 years, but now I'm doing a master's course. So I'm doing a master's of IT, specialization in AI. So this is my second semester, and I've started literally today. Today's the start of the second semester. So earlier in the day you would have seen me studying for like 5 hours for 2 different subjects. But yeah, don't know how long I can keep that up for, but we'll see. But JB does it. You know, I do relate a lot to I just learn things as I need them, right? Because same, I try to just learn things as I need them. And I want to avoid tutorial hell, for sure. But I do also love just coding as well, you know? Coding things, especially like having this keyboard with me, what I come to appreciate is Vim, I guess, weirdly. I don't know if it's that weird, but when I was typing just before, like for the first time, I started to enjoy typing in Vim. Not that I haven't been before, but it's always been less smooth. It's always broken some train of thought, but now it doesn't. And I think something like clicked today in terms of my Leetcode that I did today. So I did a Leetcode problem, a single one, but it was like the longest one that I had to write. But linked list, LRU cache. You know, this is the amount of code that you had to write. But, you know, throughout writing all of this, it just felt like, I didn't need to think about key bindings throughout the whole thing. Like, I was just writing with muscle memory. You know, that's success. It feels good, you know, it feels good. It feels like you're in an actual, I don't know, state of something. I don't know how to explain it properly. But yeah. Yeah, flow state. It was a flow state. That's it. That's the word. But, you know, I still stomped on like bugs on the problem, and then I looked at the solution, but still pretty good. I have a dactyl manuform myself. GitHub tightly it. You want to see it? Sure. I mean, here's the thing. I don't know what you mean by GitHub tightly. Title or tight. I don't even know if that was spelt correctly. Dactyl Manuform. Oh. Oh. Radio. I think I've seen these on like Reddit sometimes. Myself. GitHub tightly. I'm gonna just double check and make sure I'm not dumb. Compactly. Compactyl. Title. Dactyl malform tight. A tiny dactyl malform, manuform. Dactyl manuform. The title. Yeah, okay. Damn, that's clean. Damn. Okay, so it's low to the ground and has 3 thumb buttons. Programmed with QMK. Mine is that, but black. Damn. Mad. That does look sick. I'm not gonna lie. You know, the concaved 3-button simple design, almost matte-ish, matte blackish. That's pretty sick. The title is a dactyl without the bulky look. It is as low as possible, and the walls are as light as possible as well. I dislike the big thumb clusters that Manuform keyboards typically have, but they require too much. They have required too much thumb movement, so I went with a Korn-inspired 3-key thumb cluster. Was it? So here's the thing. How do you even make this? Is it? It's not 3D printed, right? I'm dumb to say it's 3D printed. Or is it? I mean, is it true that a lot of keyboards, Ergo keyboards, are 3D printed? Maybe. I'm not sure now. I press the 2 top thumb buttons at once for a mouse layer, so I can use the mouse without taking my hands off the home row. I would use Vim, but I feel it's better to customize the keyboard rather than the editor. And yes, it's 3D printed. I see. Wait, okay, so let me read that again. I press the 2 top thumb buttons together for a mouse layer, so I can use the mouse without taking my hands off the home row. How? Wait, but isn't a mouse, a physical device? Without taking your hands off the home row? Are you telling me that a mouse layer then is just key bindings to move a mouse hand up or down or left and right? I would use Vim, but I feel it's better to customize the keyboard rather than the editor. Ah, yeah. Right. I get what you mean, I think. So, a cursor, right? As in a mouse cursor. On the other hand is left click and right click. Damn, I see. I feel like it's not just using the mouse while using Vim. Vim also has many other useful options as an editor. I mean, boys. Once I log into WSL, I got my Neovim editor. NVim, boys. NVim. Hope. So wait, does that mean then JB does it? You use VS Code? Yeah, there are hotkeys for every action, and since my small keyboard actually has like 1,000 programmable keys, I can hotkey everything. Mad. Valid, valid, valid. You know? I think, you know, I just want to try Neovim. See how far it can take me. And also figure out its limitations, which I've already found so far a few. To be honest, I feel like, you know, when I was using VS Code before, I crotched a lot on extensions such as GitLens to help with Git, or just doing Git using the VS Code sidebar that they have, the source control. I used to do that, but now I'm just using Git from the terminal, and I'm fine with that now. But I think the pain point that I'm experiencing is, you know, you have to always Control Z out of your editor and then do your Git commands and then FG back into your editor. So that's one nitpick that I found that was different, bad, I guess. But also, I guess, just seeing the diffs. I haven't actually properly looked at how to look at diffs with Git. I'll figure it out at some point. But, you know, with VS Code, I used to look at the diffs before I committed everything. Now I just haven't. But I have to learn that again, basically. Fazal says, I just use a different terminal for Git and other commands. Yeah. That makes sense. That's fair enough. Just have like one terminal here and then a second terminal on the side. You know, that would be the sane man's way of doing things. And then there's people who use tmux, and they use emulate, like splitting here. Control B. Percent symbol. And they do the splitting like this. You know, I've used this for a while. It just means I actually rarely use this. I almost forget the key bindings. Never mind. You don't know how to use tmux in Windows? Neither. I'm using it in Linux right now. Don't even bother with Windows. Despite running on a Windows computer right now. You gotta just like do all development in Linux. Like there's no way around it. Even if you open up VS Code, open it up within WSL if you're on Windows. My personal belief, my personal recommendation. Okay. Alright, there's still quite a bit here. I want to finish the box model. Do all these knowledge checks. I could do all these now probably. Scrim. Slaying the dragon offers a valuable resource for understanding the box model. Whoops. It's not what I want either. Ooh. Damn. You're gonna make me watch a 17-minute video? Maybe I will, you know. At some point. But I'm gonna just put this to my watch later. Good. Okay. What does the box sizing CSS property do? You can decide whether you want to do a border box or a what's it called? Content box. What is the difference between the standard and alternative box model? While the standard is the content box and the alternative is the border box. Border box encapsulates all the way until the border, and the standard just encapsulates all the way to the content section. Okay, would you use margin or padding to create more space between two elements? Padding, margin. Would you use marginal padding to create more space between the contents of an element and its border? Padding. Would you use marginal padding if you wanted two elements to overlap each other? If you want two elements to overlap each other. I mean, padding. Because in the overlap, it was the padding, right? Or was it the margin? Maybe it was both. Maybe you can argue it's both. No, you can't. Right? Margin, AT. I mean, that might just be in line. I mean, it's kind of overlapping. You know, it does overlap a little bit. I don't know, I can't say. How do you set the alternative box model for all elements? You use HTML. Maybe I'll write it out. HTML followed by curly braces, say box display. I don't think that's right. I got this wrong. Box display, border box, or something like that. I know it's border box. And you need to specify the all tag, and you inherit. Well, it's not called box display, right? But that's the only thing that I've gotten wrong here, I think. So if I go and check, it's box sizing, and yeah, box sizing, inherit border box. And also colon before colon after. 2 colons apparently. I don't know why. I don't know what the colons in before and after mean, to be honest. Maybe it's worth going to CSS tricks. I'm a big fan of resetting box sizing to border box, so much so that we have a special day of the year around here. But there's a little adjustment to settings that may seem like a pretty good idea. Here's the adjusted version. Explain further, let's say you have a component that was just designed to work with default content box sizing. You just want to use it and not mess around with it. Trouble is that doesn't actually reset the entire component. Perhaps there is a header inside the component that expects to be a content box world. If this selector is in your CSS in the old way of doing a box sizing reset, then that header is in content box. As you might expect, it's border box. In order to make the reset easier and more intuitive, you can use the inheriting snippet up at the top there, and use the inheriting will be preserved. D. Okay. Oh. How do you center an element horizontally? Margin auto with width equal to some value. Yep. Cool. Cool. Mark complete. However, I'll just finish off that page first. Move on to the next page. Close that one. Keep that open. Shift T? No. How do I open a closed tab? Okay. All right. Yeah, let me finish this off. And we'll be happy with the day. We'll be happy with the day. Because it's been straight 9. Gotta stay active as well. What is it? I gotta stand up. Because apparently sitting is the new smoking. Okay. Okay, negative margins. Alright, I think I know negative margins enough, to be honest. Ooh! And that's it. We're good. We're done. Alright, we can close that. Block and inline. It's 9:06. Yeah, I'll call it a day. Alright. Thank you for tuning in, whoever it is that is still here. The one concurrent viewer. I appreciate you. And yeah, we're gonna call it a night. Did a good work. 2 study things. Oh, 100. Sovereign. It's you. I understand. You never spoke, man. Alright. All good. Was great. We are at the same point in life. Salute to you too, Sovereign. JB does it. What do you mean we're at the same point in life? What, studying? Or more specifically? Pretty much studying. I would assume. Okay, let's see. What other final things do I need to do? In school, studying similar topics, learning web dev and such. Epic. Let's go. We're doing this together. Leetcode 2, let's go. All of them. Glad to know someone is as, I guess, in it. But good, I'm gonna keep on trying to consistently do one Leetcode question a day at the minimum. You know, as hard as it may seem, since I have to balance schoolwork as well. And also eating and exercise, right? I did all the exercise I needed before I did the stream starting today. So I'm alright now, you know, I haven't been sitting all day. And arguably, I feel like I've only, I feel like I've stood today more than I've sat in general. So I feel like I'm okay. I could be lying if I look back at the VOD and see that 5 hours of my time is not standing. I could have been sitting the whole time actually. I wasn't thinking. Alright, anyway. Calling it a night. Thank you for tuning in, guys. Appreciate the chats that we've had. Some thoughtful shit. I have a quick body weight training routine. Gym takes too long for me. That's good. You know, I even did a 5-minute workout at one point. I just did that like 5-minute workout every day for like 3 years. We're talking from high school at the age of 16 to like, yeah, 18, 19. I mean, before I started going to the gym basically. And so the routines, it's all about the routines. And I would say, you know, I attributed, you know, those 5-minute workouts, technically, okay, back then, 16 years old, I did like these 15-minute workouts. I did them like pretty intensely. So I do have like, I'm kind of ripped underneath, I would say. But like modestly ripped. I'm still skinny. But you can see predominant muscles. So I feel good about that, you know? From that age onwards, like I felt good about my body. Like ever since. What can I say? Maybe it's a bit TMI, to be honest. I don't know, because I don't want you going imagining what I look like underneath. I just made it a whole lot weirder for no reason. I'm sorry. Three sets of pull-ups, push-ups, rows, pistol squats, reverse glute bridges. Actually not that quick. Yeah, fair enough. That's actually solid. 3 sets of pull-ups, push-ups, rows, reverse glute bridges. Reverse glute bridges. I gotta look that up. Okay. Maybe. Oh. Right. So the glute bridge, reverse glute bridge. That would kind of make sense to me. 3 sets of pull-up, push-ups. So here's the thing, right? These are all like body weight exercises. Yeah, body weight training. What am I? You told me body weight training. Yeah. Same. Pretty much in high school, I also did bodyweight training. And now I'm just doing like, what is it? Like 4 different things. It's like legs, and it's legs day, right? Leg day. It's shoulder and abs day. Also, I actually don't remember all of them because it's actually all in an app. Backs and biceps. Chests and triceps. There we go. I don't like, it's weighted training that I do now. But even with the weighted training, I've done it for 2 years. I'd say like I'm plateauing. I've plateaued a lot. In the sense that when I started 2 years ago, and now I still look the exact same. Mainly because I don't eat any differently. Personally, at least. I stick to like I don't eat snacks, oddly enough. Like I have no motivation to eat snacks because personally I feel as though that if I do eat, my hands are gonna get dirty. I'm gonna have to brush my teeth maybe. I'm gonna be thinking about chewing my food rather than thinking about the work that I'm doing. My keyboard's gonna get dirty. Stuff like that. Too much of a worry, a hassle to eat snacks. Alright. I'm gonna call it there. Good chatting. And thank you for tuning in. Peace.